Okay, let's try number 2 for the summary review, number 7, and the function was 2x squared over x squared minus 1, so I already wrote it in the y form. And I factor the bottom. So again, we'll look for intercepts, first of all. That's always a good thing to check for, x and y. So when x equals 0, when x is equal to 0, I have 0 over 0 minus 1, 0, so that's just 0, so I have the point 0, 0 on here again. Okay, kind of like number 2. We can check it for odd or even because I see only even powers, so if I take f of negative x, if I put negative x in here, that's just going to become the same thing. That's the same thing, so that's the same thing as f of x. So that tells me it's an even function. Well, that's nice because that's going to save me work because I know if it's an even function, it's symmetrical to the y-axis. Okay? So try to remember that. If f of negative x equals f of x, it's even. So we have all even powers. I hope you learned that in pre-calculus. You might have forgot it. And if f of negative x equals negative f of x, like we had in number 1, it's an odd function, it's symmetrical to the origin. So here we know we're symmetrical to the y-axis, so we only have to graph one side and then reflect it about the y-axis, so that's going to save us some time. Okay, so look at the degree of the top and the degree of the bottom. They're the same. That means I have a horizontal asymptote at y equals, and what's the ratio of 2 over 1? Just 2. 2 to 1. Okay? And then I've got vertical asymptotes at any value that makes the denominator 0 that doesn't simplify out. So my vertical asymptotes are x equals 1 and x equals negative 1. Actually, I should say negative 1 and 1. Okay? I'll say negative 1 here and positive 1. So we can put those in with our intersection points. So my vertical asymptotes are 1 and negative 1. And negative 1. Okay. And then my horizontal asymptote was y equals 2. That goes on like this. So now to check, because of the symmetry, I just have to check and see what's going on around either of the asymptotes. So I'll try negative 1. And remember, we're going to use this small approach method I mentioned a little bit in the last one. So we're going to see what happens as x approaches negative 1. And let's start with from the negative direction. So we'll put a little negative. That means as x approaches negative 1 from the left. That's what this means, as x approaches negative 1 from the left. Okay, so what happens? Well, let's look at our expression here. We have y equals 2x squared all over x plus 1 times x minus 1. So we can just substitute that. Kind of wrote that kind of sloppy there. Trying to get this all in this room here. So it should be y equals like that. So let me just white out that part up there, get that out of there. Now what we're going to do is we can substitute in some value. See, the only problem we have is when x is negative 1. We don't have a problem when x is 1 because that's okay. So we can substitute those values in. So I could say y equals, and if I put 1 in here, I get, or negative 1. If I put negative 1 here, that's going to be negative 1 squared, which is 1, so that's going to be 2 on the top. And if I put negative 1 in here, I get negative 2, so this part's okay. But if I put negative 1 in here, I got problems, so I have to keep that. That's where I have issues. And this is just becomes 2 over negative 2 is just going to be negative 1. So I got negative 1 on the top, and I got x plus 1 on the bottom here. So this is kind of how it behaves around negative 1, except this is going to be a problem. So we use a small approach. So as we get closer and closer to negative 1, so as x approaches negative 1 from the left, all right? So we're going to be over here. Let's say we might have negative 1.99999, something like that. Well, no, negative 1 point, real close. So let's say we would have negative 1 all over. And as we get really, really close, we're going to be really close. So this is negative 1, that's negative 2. So this is negative 1.00001. That's going to be just to the left of negative 1. It's just a little bit more. Now so that's a kind of a good approximation for what's happening right around there. Okay, as I'm approaching negative 1 from the left, from this direction. That's the minus direction. Okay. Now if I take the difference here, now I still have the negative 1 on top from simplifying here. And if I take the difference, this is going to be a little more negative, won't it? Just by a little bit, so it'll be negative 0.00001, or a lot of zeros, it doesn't really matter. And if I take a look at that, what's a negative over negative? It's a positive, so I've got a positive. And I've got 1 divided by a really small number, which means it's going to be a very, very big number, so I can say positive infinity. So that's what's going to happen. So I can just sketch that in now. And say I'm going to go towards positive infinity, so I'm going to go up this direction. And I'm going from here, my asymptote, so I'm going to be going like this. Now, what you could do is you could try some values. You could try negative 1.5 and put it in all this and see what you get. So that's another way to do it, but it's like some substitution issues. So, because if you put negative 2, you might, well, even if you put a negative 2, you might be okay, but you still have to put it in all this stuff. So that's the way you probably learned how to do it in pre-calculus, although this approaching is a little bit more of a calculus technique. Okay, now let's see what happens when we approach negative 1 from the positive direction. Well, we already did the simplification, so we know, again, right around negative 1, this is okay, and this is okay, that's negative 2. This is the problem, so I can write this as negative 1 divided by x plus 1. And let's say that's going to be negative 1 all over. Now this is going to be just to the right, or the positive direction, so that might be negative 0.9999. I'm almost at negative 1, I'm real close. I want to see what I'm doing there. And then that's going to be plus 1. Well, if I look at this, this is going to end up being negative 1 all over, and 1 minus this is going to be positive. So it's going to be positive point, and then 1 minus 0.99999 is just positive point. It's a very small number, okay, because this is real close. So I got a very small number, but it's positive because 1 is bigger than 0.9999. So I got a negative over positive, that's a negative. And 1 over a very, very, very small number is a very, very large number, or infinity. So I'm going to be down here at negative infinity. So there we go. And I know it goes to the point 0, 0, so I have something like this. Now the fact that I have an even function, this makes it a lot easier, so I just reflect it. So this is going to be reflected over the y-axis, so this is going to go like this. And this is the same thing over here, so it's going to end up looking something like this. Now you can try some different checkpoints if you want, but just we want to sketch, and that would be fine. Okay? Something needs to be getting closer to the line. Make sure you show that. Okay, and if we graph it, you can check your calculator. And there's the function, 2x squared divided by x squared minus 1. And if you graph it, that's what it looks like. And you can just see your asymptotes. And if you want to see the y equals 2 asymptotes, you could always go back and you could put down here y equals 2. And you'd see that asymptote there. There's the, yes, how it's so close to that asymptote. Approaches it. Okay, so that's number 2.